Hello and welcome to Otten Math. In this edition of Otten Math, we are going to talk about trigonometry and also trig ratios. We're going to go through two lessons in one, just because they're so related. And the respective chapters are going to be in geometry textbook are going to be 9.9 and 9.10. Okay, so let's talk about trigonometry. Right, so trig ratios are going to define the relationship between side lengths and angle measures in a right triangle. And so we define sine as the opposite length over the length of the hypotenuse. So sine is going to be opposite over hypotenuse. Cosine we define as a relationship between the adjacent side and the hypotenuse. And then the tangent is going to be defined as the relationship between the opposite side and the adjacent side. So again, sine is going to be the opposite over hypotenuse, cosine the adjacent over hypotenuse, and tangent is going to be opposite over adjacent. So now when we talk about the sine of some angle measure, or the relationship, we're talking about it in relation to some angle measure or some location as a reference point. Because if I say the sine of angle B, that's going to be a relationship between the opposite side, which is 4, over the hypotenuse 5, and then when I say the sine of angle A, that's going to be the relationship of the length of this side here with a measure of 3, so the opposite over the hypotenuse. So the opposite side is relative to the angle that's being questioned, or from which we're taking the trig function. So the way that you can remember these relationships is an acronym called SOHCAHTOA. So I have sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to the opposite over the adjacent side. So SOHCAHTOA gives you all that you need to know in terms of the relationships between the side lengths and the trig function. All right, so let's take a look at how that works out. So if I say the sine of angle A, then the value that I'll get is going to be, in this particular angle, will be 3 over 5. So 3, I have the sine of angle A, it gives me the opposite side over the hypotenuse. Sine of angle B would be the opposite side, again, so it's relative to the angle in question. The opposite side is going to be a side that has a length of 4 over 5, and then the sine of angle C is going to be 5 over 5. So the sine of 90 degrees ends up being 1. Just as a side note. So sine of 90 degrees is equal to 1. All right, so if we take the cosine, I have the cosine is the adjacent over the hypotenuse. So cosine of angle A is going to be the adjacent side over the hypotenuse. The cosine of angle B is going to be the adjacent side, not the opposite side, over the hypotenuse. And the cosine of the 90-degree angle ends up being 0 over 5. And we'll get into that discussion. You'll get into it in Algebra 2 when you talk about the unit circle. But let's just say that for now the cosine of 90 degrees is going to be equal to 0. And then finally we take a look at tangent. I have the tangent of angle A is going to be the opposite over the adjacent, so TOA. So we go back to our acronym SOHCAHTOA. So we have tangent is equal to opposite over adjacent. So I have the tangent of angle A equals the opposite side, or 3, over the adjacent side of 4. The tangent of angle B is going to be the opposite, or 4 over 3. And then the tangent of C is going to be the opposite over adjacent side, which ends up being 0 again, relative to what we got for the cosine value. And in this case, the adjacent side as 0 makes tangent of 90 degrees undefined. So you can type that into your calculator, tangent of 90 degrees, and you'll see that you're going to get an undefined measure. All right, so we're going to go through a couple quick problems, and we're going to move on to another part of the lesson. Okay, so in most cases, you're going to try to use your calculator, but when we have a 45, 45, 90 triangle or a 30, 60, 90 triangle, you can provide the value for sine, cosine, and tangent based off of the relative values that we've already established for this family of triangles. So I know in this case that in a 30, 60, 90 triangle, this side is going to be x, this side is going to be x root 3, side opposite the 60-degree angle, and this side is going to be 2x. Okay, so when we determine what the value is for sine, then remember going back to our acronym, so PTOA, remember it's going to be the opposite over the hypotenuse value. So we figure out that sine of 60 degrees is equal to the opposite, or x root 3, over the hypotenuse, 2x. The x is reduced to 1, and now we're left with sine of 60 is equal to root 3 over 2. So not necessary to use your calculator, and in fact, on the exam I will not allow you to use a calculator for some of these equations or trig ratios. Cosine of 60 degrees. So remember, cosine is equal to the adjacent side over the hypotenuse. So the adjacent side in this case is going to be x, and the hypotenuse is 2x. And again, this is x root 3. So when we take the value of the cosine of 60 degrees, we see that the cosine of 60 degrees is equal to the adjacent side, which is x, over the hypotenuse 2x, and that is equal to 1 over 2. So the cosine of 60 is 1 over 2. All right, so next we're moving on. We have the cosine of 30 degrees, and so we mark up the values again, 2x, x root 3, and x. So the cosine of 30 degrees gives us the adjacent side, or x root 3, over the hypotenuse, which is going to be 2x. So I have the cosine of 30 degrees equaling the adjacent side, or x root 3 over 2x. Again, the x is reduced to 1, so I'm left with root 3 over 2. Now, if you'll recall, the cosine of 60 degrees is equal to root 3 over 2, and the cosine of 30 degrees is equal to root 3 over 2. And I think you can figure out that the sine of 60 degrees is equal to root 3 over 2. So you can see that the relationship of the side lengths is the same between sine of 60 and cosine of 30 degrees. Okay, so remember, let's go back to the sine of 30 degrees in case you've forgotten. So, the sine of 60 degrees, we found out that it was root 3 over 2. So again, the opposite value over the hypotenuse. It was x root 3 over 2x. That's the sine of 60 degrees. And then we figured out that the cosine of then 30 degrees is equal to the adjacent side, which is the opposite side when you're measuring sine of 60 degrees, right, over the same hypotenuse. You end up with the same value for cosine of 30 degrees and sine of 60 degrees. All right, another couple problems. What's the sine of 30 degrees? So again, we write down our relationships. I have x root 3 and 2x, and I'm going to determine that the value of the sine of 30 degrees is going to be the opposite over the hypotenuse, which is going to be x over 2x, which is equal to 1/2. And as you'll recall, the cosine of 60 degrees was also equal to 1/2. So the sine of 30, cosine of 60, and the cosine of 30 and the sine of 60, respectively, are all going to be the same value. And that's essentially what I'm trying to point out to you. Okay, what is the tangent of 30 degrees and what's the tangent of 60 degrees? Okay, so we write down our relationships again, and we see we have 2x as the value. And it doesn't really matter what x is, because x in whatever case we use is going to end up reducing to 1, because we have some value of x over x. So the value that we assign to x as a variable in the end, or the limit, does not matter, because the function for the trig ratio will always reduce the x values to 1 and make that irrelevant. So on the side opposite 60 degrees, it's x root 3, and the side opposite 30, I have x. The tangent of 30 degrees is the opposite over adjacent. So tangent of 30 degrees is equal to the opposite value, x, over x root 3. These reduce to 1. Now I have 1 over root 3, and we have to rationalize the denominator by multiplying by root 3 over 3, or root 3 over root 3. which I say is just like hairbrushing, because root 3 over root 3 is equal to 1, and I'm rearranging the expression to make it a value that does not have a radical in the denominator. So this ends up being root 3 over 3. So tangent of 30 degrees is root 3 over 3. And then the tangent of 60 degrees, again, is the opposite value over the adjacent value, which is going to be x root 3 over x, which gives me just root 3. Okay, so you can type these into your calculator, and you can figure out that these are the values that you'll get. What you do is you type in tangent and then the degrees, and always make sure that your calculator is in degrees and not radians. Common problem is for students to have the calculator unfortunately modified as, at least in this case, as a radians value, and you end up getting a different value than what's determined here as a tangent of 60 and a tangent of 30. So just double check to make sure you're getting those values before you come to the test. Okay, what's the sine of 45 degrees? So now we're on to 45, 45, 90 triangles. And I established my relationship, 45, 45, 90 triangles, as x, x, and x root 2. And so the sine of 45 degrees is going to be the opposite over hypotenuse, which is x over x root 2, which gives me 1 over root 2. And again, I have to multiply by root 2 over root 2 to rationalize the denominator, which gives me root 2 over 2. Now the cosine of 45 degrees is going to be the adjacent side, or x, over, and it doesn't matter which angle you're talking about. It's going to be the adjacent side over x root 2, and it's going to be the same as sine over 45, or sine of 45. So cosine of 45 and sine of 45 are the same value. You can try that out in your calculator, and you'll end up with the same value. Okay, last question, what's a tangent of 45 degrees? So tangent of 45 degrees, I have, again, we're going to set up our values. I have x root 2, and again, it doesn't matter what the value is for x, because x will be reduced to 1 as part of the trig function. I have x and x. Now I'm taking the tangent of 45 degrees is going to be, and either one will work. It's going to be the opposite over the adjacent, and you'll see that the opposite over the adjacent side is just going to be equal to x over x, or is equal to 1. So you can calculate this again using your calculator just to verify that what we're doing is in fact correct. Okay, so we're going to move on. We're going to talk about trig ratios. And in the trig ratios, we're going to talk about angle of elevation and depression. And also we're going to talk about how to calculate values when you don't have a value of 45, 45, 90, or a special family of right triangles. Okay, so let's talk about angle of elevation and depression. So the angle of elevation and depression are always made with the horizontal. So in this case, this angle measure here that I've highlighted is going to be the angle of elevation, and it's the angle that's formed by the horizontal, always the horizontal, and the line of sight. So we call this line, it's going to be the line of sight. So line of sight. And the highlighted angle in blue is going to be your angle of elevation. Now commonly the issue is more with the angle of depression, where people confuse what the angle of elevation is, but the angle of elevation and depression are not made with the line of sight and the vertical, they're made with the line of sight and the horizontal. So just to make sure that you get that straight, please don't mess that up when it comes to the test. Okay, so angle of depression, again, it's the angle that's formed by the horizontal line and then the line of sight. And now we're going to take a problem, just to give you an example. Okay, so I have an observer on a cliff 400 meters above sea level. The angle of depression of a ship is 42 degrees. What is the horizontal distance from the base of the cliff to the ship? And what is the distance from the observer to the ship? So we have two question marks here, distance from the base to the ship and distance from the observer directly to the ship. So we're trying to find out what the hypotenuse is in one of the legs of the triangle. So we're going to use trigonometry to figure this out. We're going to use our calculators or a trig table to figure out the value. And the way that we're going to set this up is we're going to identify, we know that the horizontal line is going to be parallel with this line here, the basically the ocean. And we can figure out what our angle measure is for the angle of depression, because that's given as 42 degrees. So we know that this angle here is also going to be 42 degrees because we have alternate interior angles that are congruent between two parallel lines cut by a transversal. So I have an angle measure of 42 degrees here. And I'll go through this in more detail in just a second. We want to identify both the hypotenuse and the adjacent side given the opposite side. So let's first identify what the hypotenuse is. And what we're going to do is we're going to set up our trig function by saying that and we'll remember what trig ratio we're going to use. We need the hypotenuse and we have the opposite. So we're going to use sine. So the sine of 42 degrees is equal to the opposite value, or 400, over the question mark of the hypotenuse. All right, so what we want to do is you're going to go to your calculator and you're going to type in you're going to type in 400. So let's rewrite this algebraically. We end up with question mark is equal to 400 over the sine of 42. All right, so I multiply by everything by question mark. I divide both sides by sine of 42, and I'm left with question mark is equal to 400 divided by the sine of 42. So 400 divided by sine 42 gives us 597.8 feet, or meters, excuse me, 597.8 meters as the length or the distance between the observer and the ship. Okay, so we figured out the distance between the observer and the ship directly, but now what about the horizontal distance from the base of the cliff to the ship? So in this case, we know that we have an angle measure of 42 degrees. We have the opposite side, and now we need to figure out what the adjacent side is. So based on what we know about the trig ratios, we are going to use, so what we want is we want a relationship between the opposite side and the adjacent side, and we realize that that is going to be tangent. So the tangent of 42 degrees is equal to the opposite over the adjacent side, which is equal to 400 over the question mark. Now we could also use the value that we just got for the hypotenuse, 597.8 meters, and solve now using cosine, or the adjacent over the hypotenuse, but we're going to stick with the 400 meters for now. And we use algebra to rewrite the equation as the question mark is equal to 400 over the tangent of 42 degrees. So again, we need to go to our calculator or our trig table. We type in 400 divided by the tangent now of 42 degrees, and we end up with 444.2 meters. So 4.2 meters as the length from the base of the cliff to the ship. And I just had to do a double check to make sure that I wasn't in radians. So anyway, moving on to, let's talk about what process we just went through. We talked about angle of elevation and depression. And now we're going to go through a process of saying that you know that given the Pythagorean theorem, if you have two side lengths in a right triangle, you can figure out the third, right? You have a squared plus b squared is equal to c squared. So if you have any two of these lengths, you can figure out what the third length is going to be. We use trigonometry in right triangles if we're given one side length and one angle measure, excluding the right angle, to find another side length, or potentially another angle measure. But the other angle measure typically is going to be very straightforward. If you already have two angle measures, you can just subtract those two from 180 degrees to get the other angle measure. But in this case, what we're trying to find out is another side length given an angle measure and one side length. So the first thing we need to do is determine the relative side for which you want a measurement. In this case, we say it's the hypotenuse. It could be a leg, and it could be, in this case, it would be the adjacent side or the opposite side. Remember, it's all relative to the angle in question, or the angle that we have the information for. But of course, we could use we could figure out what the other angle measure is and use this as the opposite and this side as the adjacent. But we'll work with what we have for now, and we know that 39 degrees is the measure of, we're going to call this angle A, Actually, let's call it angle B, because we have A for adjacent in the right side. So we'll say this is angle B, this is angle C, and angle D. And so we first determine the relative side for which we want a measurement. And it's going to be, in either case, it's going to be the hypotenuse. Second, determine the relative side for which you have a measure. So we have the angle measure for 39 degrees. What side relative to the 39-degree angle do we have the measure for? In this case, we have the opposite side. So we have the opposite side, and we're trying to figure out what the hypotenuse is. So this means that we're going to need to use sine as our appropriate trig relationship. So remember SOHCAHTOA. So opposite over hypotenuse is what we're looking for. Sine establishes that relationship. And then fourth, we're going to use the sine of the angle measure in algebra to determine the length of the desired side. So we're going to go through the same thing we went through with the angle of elevation depression. We're going to say the sine of 39 degrees is equal to opposite side, which is 7, over the question mark, our hypotenuse. And we rewrite as the question mark is equal to 7 over the sine of 39 degrees. So we have to go back to our calculator or a trig table if it's not 30, 60, 90, or 45, 45, 90 triangle in this case. So I type in 7 divided by the sine of 39 degrees, and I end up with 11.1 as the length of my hypotenuse. So again, let's walk through this step by step. We have one side length and one angle measure. First thing we need to do is determine the relative side for which you want to measure. In this case, we determined that it was the hypotenuse. Second, we determine the relative side for which we have a measure. In this case, we were given 7 as our measure. So we determined that's the opposite side relative to the 39-degree angle. Third, determine the appropriate trig relationship or ratio. In this case, we knew we wanted the hypotenuse. We had the opposite. We know that sine establishes that relationship between opposite and hypotenuse. And fourth, we used our calculator in algebra to figure out that the sine of 39 degrees is equal to 7 over what value, the hypotenuse, that we wanted. And we solved for that question mark, and we ended up with 11.1 using our calculators. Okay, so quite a bit of information for you, but I wanted to combine the two lessons because of their relationships. I hope you got it all. If not, come back and visit us. We'll do some practice problems for both chapter 9.9 and 9.10 on Introduction to Trigonometry and Trig Ratios.